Hello everyone. Sorry about the wait there in the start, but I was just getting set up. So, I'm sorry about the technical difficulties on Wednesday, but um, I hope to remedy that by giving a quick highlight of how the overall session went with the testing of my new task for the AI. So, first, in basically the stream cut out after 5 minutes. So if you want to go watch the first 5 minutes of the testing, then you can. But I will give an entire recap or an entire update just to cover all the bases. So first off, I had my. If you didn't watch the last stream update, then basically what I had my new task for that I coded for the AI to perform, and I had my friend Thomas. He's actually my roommate. I had him come on the stream and try and play the new game or task, and his goal was to figure out how to get the score in the top corner, like we have the score on the game here, but on the new game, the score works a little differently. His job was to make that score number get as high as possible, and that was the only instructions I told him, other than don't hit like the escape key and things like that. So he had to find the keys that he needed to were used to do different mechanisms in the game, in the task. The game itself is a somewhat survival game, so there's an environment and there's different aspects, like there's a health bar, there's a battery life bar, and the point is to just survive. But the way that you survive is by keeping the score as high as possible, because if your health bar gets too low, then the score drops significantly, and if your battery bar gets too low, the score drops. But that's a basic overview of it. There's also other complicated situations. So there's enemies that will randomly attack, but that's only if you get far enough away, so if you explore enough. And there's also food, so you have to go find the food to get your health back up, and then the battery can be charged in a area that is lit. So there's a light where you start off, and when you come back to that area where the light is, then you can charge your battery. So if you do watch the 5 minutes, which I encourage you to, because it does at least show the layout of the game. You'll see that the little character on the screen, which I have decided to call Jeffrey, because that just seems adorable, and it's a very small little robot looking thing, and I think that that's a great name for a very small looking robot thing. So Jeffrey starts off in the corner of the environment, and this corner is the corner that has the light in it. So when Jeffrey is in the light, then his batteries charge, but his health goes down gradually over time. It is a constant rate. I believe it's like it's 1 health per second out of 100. So in 100 seconds, Jeffrey dies, unless Jeffrey goes and gets food. So what my friend Thomas was trying to figure out was, first off, how to move around. Second of all, what the meters on the side meant. So there was an orange meter and a blue meter, and the orange meter was the health bar and the blue meter was the battery bar. And the battery bar didn't come into play until later, because for the most part, when he was trying to figure out the controls, he was still within the light, so anything he did do, the battery bar did not go down. but he flailed around a little bit, but that's exactly how the AI would handle it. It's basically that the AI has to try everything first, or try a large amount of things before it sees something that's actually doing well. So that's how Thomas went. How it worked for Thomas. So he finally got the controls of how to move Jeffrey around, and then began exploring. So once he began exploring, he got a little too far away from home, and the enemies started attacking. And then when the enemies attack, your health drops really quickly unless you do something about it. So so Jeffrey has a bunch of assets that he can use when told to. So the assets are a radar, a camera, a gun, and a sprint mechanism. So the radar shows if anything is occupying a space around the screen. So in the field of view. So if the screen is 250 by 250 pixels, then anything filling up a space of 10 by 10 pixels within that sector that is visible in your field of vision, then it pops up green on the radar instead of the normal black, which is symbolizing not being able to see it. So then the camera is somewhat like the radar, except limited around Jeffrey. So it's a smaller circle than the normal field of view. You can see exactly what is occupying a space. So you can see if it's an enemy, or you can see if it's a rock, or you can see if it's a food pellet. So this is beneficial if something's close to you, but it also, if nothing's close to you and you're trying to figure out what something is, then it doesn't really help, because it doesn't tell you anything outside of the circle of vision in the camera. And then the next asset is the gun, and like I said, if you get attacked by an enemy, you have to do something very quickly, or else your health will drop. So,
I love you.
Oh, okay, someone's talking to me through the window. So, if you are being attacked by an enemy, then you can fire the gun, and if you fire the gun at the enemy and you hit it, then the enemy is killed, which it just teleports to a different area in the map. So then the last asset is the sprint mechanism, and the sprint is exactly what you would think it is. It just allows you to go faster. And the problem with all of these assets is they all require battery. So the battery is something that you have to budget so that you don't get stranded out in the middle of nowhere, because yes, you can still move once the battery is all the way to all the way down to zero, but the chance that you get attacked by an enemy is very high, because you can't see the enemy coming, and you can't necessarily see rocks or anything, so you might get stuck in a certain area. So that's the basic layout of the assets. So the way that my friend Thomas worked it out was he figured out the radar, so he used that, and then he was able to see his surroundings a little bit. And like I said, it tells you that something is in a space, but it doesn't tell you what it is. So you can at least avoid rocks and more efficiently move through the area, and you can also kind of get a bearing on your area. There is some advantages to having human intuition rather than how the AI will see it, and that is the bearings you can get, because the AI will not have memory, so to say, of of the certain environment. The way I'm working it out is that the AI in general will have a data bank of situations. So it's sort of like different environments that are common, and then it will have decisions that it will act upon when it is in those certain environments. So, like I said, he used the radar, and then once he found the camera, he switched to the camera because the camera is more revealing of what is actually in a space. I believe he turned the radar off at that point, which meant that he could not see anything coming from a distance, but he could still preserve battery, which, like I said, there is a give and take, so you have to budget that. And then he realized that about the food pellets, so he realized that the food pellets would help keep the health from getting too far down. And like I said, this is one of the advantages of human intuition, because the way I have the simulation visualization going, the food pellets are the same color as the health bar, so I would think that had a little bit to do with figuring out the correlation, but at the same time, when you're moving around, it's a good possibility that you could run into one anyway, and that is the idea that would happen with the AI, is that the AI would accidentally run into one, and then the results would be positive, so then it would start to associate running into them with positive results. And then after that, he used the gun and the sprint mechanism, but not necessarily applying them in their situations, because like I said, he was randomly trying keys, so he couldn't necessarily find or remember the keys that did those actions, but I did see them happen, so I'm just mentioning that. And that is the general overview of what happened. So he was attacked a couple times, and he did starve a couple times, but I would imagine the AI is going to be much have a much harder time with stuff like that. So that, I mean, like I said, there is some advantages to having memory of environment and overall being able to associate things based off of different aspects like color. But I consider the test a success, because it did show that without any information, the game can be played. So with minimal information, the game can be played. So I'm starting work on the actual AI and the intelligence part, so that the AI can play this game, and I will be updating you guys on how that's going. But I've written out a checklist of the things I need to do to edit the current code. So, like I've explained in the past, the new program requires a second tier of, or I guess it would be a third tier of programs. So it needs a boss program, so to say, to tell the parent program what to learn about, and then also it needs a driver program to run the simulation of the real-time life, in real-time survival environment, and to constantly run this so that it can so it would simulate what would happen in an actual environment. So the driver will be constantly playing the game, but it will, throughout the time that the boss and the parent are working through the data, it will be receiving new directions and new instinctual tendencies to act upon in different situations. So The basic idea is that I have a flow chart over here I wrote on my whiteboard. The driver is playing the game and constantly writing out the different variables of the situation to a text file, and so as it's playing, it's every time it moves or anything, it writes out the variables of the environment to a text file, and then the boss program, whenever it goes through a cycle, and it'll be going through a different frequency of cycles because it could take longer to analyze things than the driver takes to move one tick on the screen. So the boss program will be taking a sample of these driver reports, and it will use these samples to find out which environments happen more, or which environments are more likely to happen, and then also how well the driver is doing. Actually, I'm not sure if it necessarily needs to know how well the driver is doing in those situations, because that's something that the parent will handle. So the boss program will read in this data, and it will see that the overall program, it will see that the environment is more likely to happen. So if the driver is stuck in one environment, then the boss program will send a message to the parent program through a text file saying, hey, we really need to work on what to do in this environment so that the driver can move to a new environment, or at least improve its score in that environment, which is the total goal, is just to improve the score. So the parent program will be taking in the orders of the boss program. So the parent program is what I already have, and so what you see over here with the numbers going by, each generation creates a certain number of child programs. So what I'm thinking is that I will have a minimal number of child programs, maybe 5 to 10 child programs, and every generation the parent program will load in the environment it needs to work on. So it won't necessarily work on one environment for a bunch of generations. It will work on one environment for one generation, then check the priority. If the boss program says that it still needs to be working on that environment, then it'll work on it again, and then it'll check it again. So then when the boss program says, hey, stop working on that and start working on this, then the parent program can immediately, or on the next generation, it can read in the new environment and start working on that environment, but then also it will keep the best and second best program from the best and second best data from the other environments, so that it can jump right in whenever that environment needs to be worked on again. So then, so the parent program is writing child programs to simulate the environment, and so it is only running for a short period of time to see if the score will go up or if the score will go down, and then but then it's when it gets a best set of decisions, it will send those decisions back to the boss program, and the boss program will edit the library of instinct for the driver program. So then the driver program will continue on with its business with the new decisions, and then it will apply those decisions. So the driver program doesn't necessarily care if the score goes up. The driver program is just doing what it's told. The boss program is trying to give the driver program the best situation for its score to go up, and the parent program is finding that best situation. So that's the general summary of the structure of how this new AI is going to work. And I have started work on this. I've started to work on the driver program. It is a little difficult to work on this because all three of the major programs are so intertwined that you can't really test it until all three of them are running. I have speculated on a couple problems when all three of the when the programs are when they're all talking to each other through text files. I would think that there is a possibility that both that two programs, or I would think only two programs. I think that the BOSS program and the driver program will have their own text files to talk to each other with, and then the BOSS program and the parent program will have separate text files. But there's a possibility that, say, the BOSS program and the driver program both try to open one text file at the same time, and I'm not completely certain if that will cause something to crash. I know if you leave a text file open, that causes problems, but I'm thinking that I might be able to at least avoid this situation, because even if it doesn't cause a problem, if the BOSS program is writing out new decisions while the driver program reads in those decisions, then it won't get all of the information it needs, because then it will only get it'll only be partially done writing out the new information. So the driver program won't have all of the info it needs to update its decisions. But like I was saying, I might have thought of a way around this. So it's not a 100% fix, but it will make it a lot harder for two programs to both attempt to read the same text file. So that idea is to have a while loop in the BOSS program where it checks to see if the first number in that text file is a 1. So then if it's a 1, then it goes through the while loop again and checks if it's a 1. So basically the BOSS program keeps waiting until the driver program is done reading the text file. And then when the driver program is done reading the text file, it will rewrite the text file with a 0 at the top, but everything else exactly the same. So then that way, the overall situation is that if one is in the middle of doing something with a text file, then the other will wait until that program is done doing whatever it needs to do in that text file. But what I've decided with the driver program is that if the I have to work it out a little bit, but I was thinking that with the driver program, if the BOSS program is working on that environment's data and that environment's instincts and decisions, then the driver program can simply not update its decisions and just go with whatever decisions it had the cycle before that. And so I'll have to work that out and make sure that it works in practice. But I think the idea is that if you're thinking about something and you're still thinking about it, you might as well go with what's worked in the past or what you were already doing. So I'm not sure if the logic completely flows there, and you're welcome to comment on that if you want to. I will be taking any suggestions that people bring up, but I think that that's the overall summary of the structure of how my new version of the AI is going to work. My one concern is that if my computer was having trouble running the HiveMind project, which was only the current tier, then I'm worried that that having 3 programs running at once might be a little tolling. But I will see, because the situation with the HiveMind program was that it had a lot of generations, and it had a lot of data to work through, and there will be a lot of data in the current version of the program, but I'm working out ways that I can minimize the toll on the CPU by doing things like how I said I was going to have a minimal amount of child programs, because it only needs to learn a little bit each time. But if the program is stuck in a certain situation, then it will continue to learn a little bit many times, so then that will eventually add up. Alright, so the structure of today's, I know I talked for a while on that, but that was the idea. The structure for today's program, for today's episode, is that I didn't really have something specific I wanted to talk about other than the AI, so I didn't think that it would be right to try and force a topic into the talk show. So I decided that today I would just play a quick song on guitar, and then I would do the normal activity in Paint that I have been doing. So I'm gonna take a short break and play an ad here, but when we get back from the ad, then I will be playing a song for you guys on guitar, and then after that we'll be moving into the random topic description with the paint drawing. So I'll be right back.